When you build on a flawed foundation, the initial cracks are invisible, but add weight, and those hidden stress fractures compound until the structure buckles. If you've sat in an AI planning meeting recently, you've probably heard the terms model, API, agent, and wrapper tossed around interchangeably. That imprecision is fine over casual coffee, but treating these distinct layers of architecture as synonyms is a direct path to expensive technical debt. Committing to the wrong layer at the design stage locks you into unexpected compute costs. It creates rigid systems that eat up engineering hours in endless maintenance cycles. Engineering resources are finite. Organizations need to pinpoint exactly where in the technology stack those hours and dollars belong. If you fail to match your technical architecture to your specific business constraints, the project will fail before your team writes a single line of code. This horizontal spectrum maps the 4 distinct operational layers of modern AI infrastructure. We have the model, the API, the wrapper, and the agent. At the base is the model, the foundational mathematical reasoning engine processing data. Next is the API, the standardized access pipeline your software uses to communicate with that intelligence. Further down is the wrapper, the interface layer making the AI's capabilities navigable for humans. Finally, the agent, an orchestration system granting the AI autonomous action across multiple steps. Choosing where to build along this spectrum requires balancing a continuous operational trade-off. You are weighing raw speed to market against deep technical autonomy. Let's start at the source. An AI model is an intricate mathematical function. It is exposed to massive amounts of data, and its internal parameters are adjusted until it reliably produces a useful output. Building or even fine-tuning your own model requires heavy upfront inputs. You have to secure expensive compute infrastructure, hire specialized AI scientists, and run continuous, intensive retraining cycles. The payoff for that investment is a precision-trained engine optimized for a niche task, like AlphaFold running predictive protein structures for drug discovery. But here is the reality for standard software integrations. Self-hosting and training models is difficult to justify for most teams. This matrix shows the alternative. Instead of paying the high infrastructure costs to host a model, you can use an API. This is a standardized pipeline connecting your app to a pre-trained model maintained by a vendor. The operational input here is lightweight. Your team sets up a standard REST or GraphQL integration, and from there, you simply manage metered access keys. The trade-off is control. An API gets you to market rapidly and removes the infrastructure burden. However, it creates absolute reliance on a third-party vendor and guarantees continuous, per-call operating expenses. If your technical team needs foundational AI capabilities, consuming an API is mathematically superior to attempting to maintain a custom model. Once you have access via an API, you have to consider who is using the tool. A product wrapper is the specialized user experience layer built directly over that API to serve everyday, non-technical users. Building a wrapper changes your resource allocation. You shift engineering budget away from AI science and push it directly into interface design and workflow mapping. Consider an application like Canva. They wrap image generation capabilities in a familiar design interface, apply brand guardrails, and translate raw text prompts into a seamless visual workflow. The vulnerability of a wrapper lies in its dependency. If the underlying third-party model changes its behavior or degrades in quality, your carefully engineered user experience can break instantly. But if your target audience requires simplicity and consistency over technical control, the wrapper is exactly where your product generates its commercial value. Models and APIs are built to answer questions. Agents are built to do things. An agent triggers a sequence of autonomous, rapid-fire actions. It accesses specific tools, queries databases, and executes commands, completely bypassing human approval. Making that function reliably requires intense engineering inputs. You have to build persistent memory management systems, wire complex tool access, and establish strict safety boundaries so the system doesn't break external software. The outcome you are building toward is a system that can perceive its environment, reason through a problem, and pursue a multi-step goal entirely on its own. The financial risk is significant. Agents can fall into continuous reasoning loops, talking back and forth to an API endlessly, generating erratic and runaway compute expenses. The reality of production environments is harsh. An agentic system that looks flawless in a carefully controlled demo is often fragile and difficult to debug when it encounters edge cases in the wild. Architect an agent only when manual workflows completely fail. For simple tasks, the heavy maintenance burden of an agent far outweighs its utility. Match architecture to user constraints. For technical users needing speed, choose direct API integration. For non-technical users requiring guided simplicity, route budgets into a product wrapper focusing on UI design. For autonomous multi-step tasks, you must deploy an agent architecture. Aligning your users' technical literacy with the project's operational budget helps manage engineering focus and reduces the risk of ballooning development costs. Keep the ultimate division of labor clear. Models provide the intelligence. APIs provide the access. Wrappers provide the usability. Agents provide the autonomy. The golden rule of AI product design is simple. Always build the absolute thinnest technical layer necessary to solve your user's immediate dilemma. Start your project at the API level, build only the necessary wrapper your users demand, and resist the urge to introduce agentic complexity until it is absolutely required to function. Raw ambition alone rarely kills AI projects. Adopting complex, heavy architectures before your team clearly understands what each layer actually does is the true point of failure.